Today we're taking a look at types of lines and angles, and specifically the angles that are formed from intersecting lines. Now before we get into it, let's take a look at a few definitions that you might be familiar with already, but we're also going to learn some new notation for these. So parallel lines are lines that never intersect. Over here in our diagram, let's say this is point J here. We have this line J to F coming across the front top edge, and this line A to B running across that back top edge. Well, those two lines are parallel, and these arrows here indicate that they will never intersect. So those arrows are indication of parallel lines. And we would say that line AB, with our proper notation for line, two capital letters, and the line with two arrows over the top, are parallel to each other. Now, the symbol for parallel are these two forward slash it lines. Okay, so we'd say AB is parallel to JF. Now there's another pair of parallel lines in here. That would be JG would be parallel to FH. And again, these arrows here indicate that they are parallel to each other. Perpendicular lines means that you have two lines that intersect at 90 degrees. In other words, they form a right angle. So down here in the lower left-hand corner, we see that angle G is a right angle. We could say that JG, this line JG, is perpendicular to the line GH. So we'll write our line GH with proper notation. Now the symbol for perpendicular is this upside down T, capital T. All right, and that just indicates that these two lines are perpendicular. They intersect at 90 degrees. Now skew lines might be new to you. Skew are lines that never intersect and are not parallel. In fact, they're two lines that are sometimes on different planes. So let's choose the orange color here, and let's color in this line segment FB. So FB would be a line, and let's change our colors back here to maybe to some green. And another line that would not be parallel to it and not intersect it would be like this back line that goes up and down, this green one here, line AC. So line AC and line FB are skew lines. They'll never intersect and they are not parallel. Finally, we get transversal. Transversals are lines that cut across other lines. So for example, we could say GH is a transversal to line JG. Or we could say line DH is a transversal to line GH. All right, let's move into some more examples, and now we're going to take a look at some angles, and angle pairs specifically, that are formed by transversals. Now remember, transversals are lines that cut across other lines. So in our example over here on the right hand side, you can see the black line that comes through G and H. GH is my transversal. This line comes through and it cuts line AB and CD. And when it does that, it forms these 8 angles. Now there's some specific names for these angle pairs, and one of those names is corresponding angles. Now corresponding angles are exactly that. They correspond to their position or location in regards to the transversal and their other line. So for example, if we take a look at this top cluster of 4, to the left of the transversal and above the line is angle 1, and you'll notice that it's circled in green. Now let's look at the bottom cluster. To the left of the transversal and above the line is angle 5. It's also circled green, so these guys are corresponding angles. So our example here, or one example of corresponding angles, is angle 1 and angle 5. Now another pair of corresponding angles are angle 2 and 6. You'll notice that both 2 and 6 are to the right of the transversal and above the line. So angle 2 and angle 6 are also corresponding. Now let's go take a look at 3 and 7. They're to the left of the line, or the transversal I should say, and below the line. So angle 3 and angle 7 are also a pair of corresponding angles. And finally, our last ones here that are color-coded orange are angle 4 and 8. And you'll notice that they too have the same position. They're both below their lines and to the right of the transversal. So that's what it means to be corresponding angles. Now let's take a look at alternating interior angles. And I'm going to change my color here back to blue. Our alternating interior are exactly that. They're on opposite sides of the transversal between the lines. You'll notice that the word interior appears here in between our two lines that this transversal is cutting across. So this is our inside. Now if we have alternating interior, then we're looking for opposite sides. So one angle pair that are on opposite sides and in between the lines are angles 4 and 5. So angle 4 and angle 5 are an example of alternating interior. The other pair would be angle 3 and angle 6. Alright, let's take a look at alternating exterior angles. And again, I'm going to change my color here. Let's go to black this time. Alternating exterior are on opposite sides of the transversal and on the outside of the line. So you'll notice up here and down below this line it says the exterior. Kind of think of it like a sandwich. In between the two pieces of bread are your interior parts of your sandwich, on the outside your exterior. So alternating means opposite sides of the transversal. So for example, angle 1 and angle 8. The other pair of alternating exterior would be angle 2 and angle 7. Alright, now for our last definition here, same side interior angles. Well, interior implies it's on the inside part here. Same side is going to imply it's on the same side of the transversal. So in this case we have the angle pair angle 3 and angle 5. They are on the same side interior. And angle 4 and angle 6 are also on the same side interior. Alright, let's take a look at a few examples here of making sure we can identify these types of lines and angles. In this picture here we have a shoebox and we want to identify a pair of parallel lines. Well, we don't see any arrows drawn in on any of these edges, but we can assume a shoebox is going to have some parallel edges. So here's segment FG and EH. Those two edges on the outside of that box should be parallel to each other. So we'll say it's segment FG is parallel to EH. We could also say the same thing about segment ED and FA. How about some perpendicular lines? Now, again, this is a shoebox, so we're going to assume that this segment AD and AB coming across this front here intersect at 90 degrees. Likewise, we could say F down to A and then across to B forms this right angle, so those would also be perpendicular. So we'll say FA is perpendicular to AB. Finally, let's get a pair of skew lines and we'll change our color up here so we can see it. Skew lines, remember, are lines that never intersect and are not parallel. So here's BC, and now we'll take this front edge coming across the front here, ED. So we'll say segments ED and BC would be skew. Alright, example 2, we're given this diagram here of some lines that are being intersected by C, F, G, and D. Well, this line here, CD, is known as my transversal. This is the one that intersects the other two lines here. We want a pair of alternating interior angles. So I'm going to give you one pair, I want you to come up with the other. The pair I'm going to give you for alternating interior are angle 9 and angle B. You come up with the other pair and we'll share that in class. How about same side interior? Well, again, I'm going to give you one pair and I'm going to say angle 9 and angle C this time. You come up with the other pair of same side interior. Alternating exterior, I'm going to go with this one, angle 8 and angle A. You tell me what the other pair of alternating exterior are. Finally, let's go to corresponding angles. Corresponding angles would be like angle 7 and angle B. I'm going to give you two of these ones. Alright, my next pair would be angle D and angle 9. Alright, you have two more pairs to come up with here for my corresponding angles. Share them with me tomorrow in class. Finally, example 3. Now we have 3 crisscrossing lines with a bunch of angles that are being formed. In this problem, we want you to name the transversal that forms a given pair and tell what type of angles they are. So for example, here's angle 1 and angle 7. Angle 1 is right here, and angle 7 is down here. The transversal is the line that touches both of those angles. So in that case, this is line S. So I'm going to say line S is my transversal, and angle 1 and 7, they are in a corresponding location. They're both to the left of the transversal and above their lines. So these guys are corresponding angles. All right, next let's take a look at 4 and 9. I'll change my color up here. Angle 4 is right here, and angle 9 is up here. All right. Now the angle, or sorry, I should say the line that forms both of those angles is the line that touches both of those angles, and that's going to be this guy right here. So my transversal is line T. And the type of angles these guys are, it looks like they're on opposite sides of the transversal and they're inside their lines. So I'm going to call these ones alternating interior angles. 2 and 12, here's angle 2 right down here, and angle 12 right here. And again, my transversal is line T. Line T is the one that touches both of those angles, and these two are also in a corresponding position. So these guys are corresponding angles. And finally we have 11 and 6. Here's angle 6 right over here, and angle 11 is right here. Now the transversal that forms those two angles is transversal P, or in other words saying that, line P. And these guys are on the same side and they're in between the lines. So these guys are known as same side interior angles.